Today we're doing the second set of notes from the statistics chapter on two-way tables. So something I recommend when you have these two-way tables is to always find all the totals as much as possible because it makes the probability go by easier. So what I mean by that is around the table I would write that there's 14 yeses, there's 14 no's, there is 15 females, and that there is, or 15 males, sorry, and 13 females. And then somewhere off to the side of your page, I would jot that there's a total of 28 people. So when we're doing these probabilities, it makes it much easier to have these totals. So the first one says, find the probability that the person did chores. So of the 28 people, so of the whole population, we know that 14 did their chores. So this would be equal to 0.5, which is 50%. For all of these, I expect you write the percent. Letter B. Again, we're dealing with the whole population. It hasn't specified otherwise. We want to know the probability the person is female. So of the 28 people, 13%, or 13 people are female. So this will work out to be 46%. Letter C is now where we're getting into this word of conditional probability, where now there's two conditions you have to satisfy. So it says, find the probability the person did not do their chores given that they're male. So whenever you see this word given, whatever's written after it is implying the population that we're using. So given that they're male, so of the 28 people, we know 15 are male. And of those 15 males, 8 did not do their chore. So notice now we're not dealing with the whole population, we were just dealing with males. So this answer is 29%. Letter D says find the probability the person is female given that they did their chores. So of the 28 people, we know 14 people did their chores. And of the people that did their chores, we know that there's 7 that are female. So this would be 50%. Okay, next one. Actually, I think I have a mistake here. This is not going to be 29%. This will be 53%. Okay, so next example. Again, we're going to start with finding all the totals. So you need to find out how much total paper, metal, glass, plastic, and other, how many recycled, not recycled, and then the total. So the total for recycled is 68. The total for not recycled is 161.2. Paper is 81.2. Metal is 18.2. Glass is 12.5. Plastic is 25.4. Other is 91.3. And our overall total that we're dealing with is 229.2. So now that you have all the totals, it makes this problem much easier to do. So letter A says find the probability the material was recycled. So notice there's no given here. We're dealing with the entire population of 229.2. So of that whole population, we want to know how much was recycled. So 68 of the 229.2 is recycled. So this works out to be 30%. Letter B. Now they don't write out the word, so that little bar that you see implies given. So it says find the probability, not recycled, given that it's metal. So the metal is your bottom number. So metal, there's a total of 18.2 metal, and of the metal, 11.9 was not recycled. So this works out to be 65%. And again, this is what we call conditional probability when there's two conditions you have to satisfy. Letter C, find the probability it was recycled given that it was glass. So our glass total is 12.5, and of the glass, 2.4 was recycled. So that is 19%. Letter D, find the probability it was plastic given that it was not recycled. So we have 161.2 for the not recycled. That's our total. That's the population we're dealing with. That of the 161.2, 24 is plastic. So that percent would work out to be 15%. So that's all for today. There is a problem on the back page that I would like you to try. Letter D is a typo. It should say probability. So this is letter D. It should say probability that you are female into hand. So there is a typo for letter D. So I would like you to try the next practice problem for tomorrow.